So we just had a video on prime factorization, and one of the best reasons to understand prime factorization in terms of working on math problems in algebra and pre-algebra is factoring out these greatest common factors when you have terms that will have common factors. So for example, we talked about in class a sort of basic example of just looking at two numbers. So we look at 4 plus 8. Obviously, we could just add these, but we want to learn the relationship between these two numbers in terms of multiplication. And essentially what we can do is create the distributive property, because 4 plus 8 is obviously 12, but we can write 4 plus 8 as a multiplication expression. And the way you do that is by factoring out the GCF. So when we look at 4, we can factor 4 into its primes of 2 and 2. And when we look at 8, we can factor it into 2, and then we have 2 and 2, because 2 times 4 is 8, and then 4 can make it down to 2 and 2. So we know that the GCF of 4 and 8 is 4, because we have a pair of 2's here, and we have a pair of 2's here, and so we can say that the GCF is 4, which means that when we actually look at this expression right over here of 4 plus 8, we can actually factor out the GCF. And so we know the GCF is 4. And so what we want to do is we want to create a multiplication problem. And we learned that we can use parentheses to do this. So parentheses, typically we have, if we were to have just a number in here like 1, we know that we can multiply 4 times 1 and we would get 4. But what we have here is an addition problem, right? So what we want to do is we want to think about the addition and see what can we leave inside that would allow us so that when we distribute the 4, we would get the original problem. So let's just see what I'm saying here. So I'm going to have the plus here. So the question again is what remains inside the parentheses once we've factored out the GCF? Well, what's also missing over here in the factor tree is a prime factor of 1. We don't talk about 1 as being a prime factor because it doesn't really change the value of the problem, because 1 times any number is just that number. But when it comes to multiplication, we know that if we were to put a 1 here, we would actually be able to say 4 times 1 is 4, right? And so we want to, again, try to create this multiplication problem. And so what's left over here, let me put a different color here, this 2 that remains from the prime factorization of 8 would be a number left inside, so that when I do factor out 4, I have a 2 remaining. And I can also check my work and see that I have 4 plus 8, because 4 times 1 is 4, and then 4 times 2 is 8. But ultimately what I've done is I've said 4 plus 8 is equal to 4 times 1 plus 2. And sure enough, if you check your work, 1 plus 2 is 3, and 4 times 3 is 12. So you get the same value of 12, but we're looking at it in a different way. And the reason why we want to learn how to factor is so that when we get involved with variables, we'll still be able to solve equations. So let's take a look at another example that has some variables in it. So if we were to look at 4x plus 8, again, we still have GCF as just 4 because 8 doesn't have a variable x in it. But if we want to factor out the 4, we still can say there's a 1 left, but then there's also an x. And so the problem just changes so that we keep the x inside. Let's look at another example. Let's say I had 3x squared plus 6x. Now, if I were to factor this, I would say 1, 3, and then x, and an x, and if I was to look at 6, I would say 2, 3, and x. Again, I want to find out what the GCF is. So I see that I have a 3, and I also see that I have an x. And so what I do is I say I have 3x, right? And then I have what remains. Now what remains is my 1 and my x here. So I'm going to say 1x, right? Keep plus, and then I'm going to say what I have left here, which is the 2. Okay, and that is the factoring of the expression 3x squared plus 6x, because they both have a GCF of 3x, which I factored out. Now I can always check my work. So if I were to distribute, I would get 3x squared plus 6x. And so sure enough, I get the original problem. So by factoring out, you're creating the distributive property, and by actually distributing, you're getting the original problem back. It's a way of working back and forth with working with expressions. And again, we're going to use this in order to solve equations. I hope this helps. Oh, one last thing is sometimes we have to work with negative numbers. And typically what we like to do is if we have a negative number on the outside, we want to factor out this negative number. So the GCF here I can say is, let's say this is 2, 5, and x. This is just 5 and 1. And so I am going to factor out 5, but I also want to factor out the negative because we basically don't want to have negatives inside the parentheses. So what we want to do is we want to put the negative 5 out. Now, since we're factoring out the negative, then we just got to think opposites here. So I still have the 2 and the x. And since the 10 is already negative, I can keep this positive. Now, because I factored out a negative 5 here, I'm going to need a negative 1 on the inside because negative 5 times negative 1 is a positive 5. And so what I've done is I've essentially changed the problem, but I don't want to have a negative inside the parentheses on the first term. And so I've factored out the negative. And this will be a valuable skill to have when, again, we're solving equations. Now, what if I didn't have plus 5? Let's say I had negative 10x minus 5. Well, remember, I want to always change subtraction to addition, so I can change this to a plus and a minus. Now, again, I do the same exact thing. I factor out the negative 5. And then what do I have left? I have 2x plus. Now, in this case, because I factored out the negative, I have a positive 1 here. So nothing really changes too much other than just being cautious of the signs. And again, you can always check your work. So I can get negative 10x, negative 5 times positive 1 is a positive negative 5, and I'm back to what I originally started.